Alright. Alright, we're into it. Okay. Alright, let's just begin somewhere, I suppose. Okay. So. MidiPunk. MidiPunk. Alright, let's bring up my workspace of everything I need. Oh, is there a dark mode in this? Beams, maybe. Appearance. Oh, heck yeah, that's so much better. Oh. Okay, let's do this thing. Alright, we have got... Now, how's my mobile cam working? Do I have a little inset? I don't for my mobile cam. That's really sad. Need one. Gonna build one. Gonna make one. We're gonna go studio mode. How do I do this? Overlays. Mobile. Add. Add a scene. We're going to find that scene, which is overlay mobile ordered. And then we can bring that down. Nice and small in the corner. I mean, I could stack it on top of me. But that's gotta be, it's gotta be a bit bigger, right? Maybe I'll check it up there. What I can do is put the logo in front of it. Drag that down. So drag that down. Mobile boarded. That logo is a little bit intense, isn't it? Maybe I can edit that. I should really get the stuff right before I go live. It's normal. Me being a dumb. Let's just resize the damn thing. It's just too big. Make it right up in the corner like that. That looks good. We'll leave that there. Alright, that's fine. So what that means is I have got... Probably hide like all my receipts and personal items off my desk if I'm going to have like a camera there. Makes sense. So, what can we see if Well, pretty messy, but what can you expect? This is really difficult. Oh, it's because it's laggy, that's why. I need to actually look at the... Okay, so there might be a better way to do this. If I flick that around the other way... Yeah, that's more like it. Okay, we're good. Now I need a stream deck. To be able to turn off that mobile view. This is stuff that, you know, housekeeping I really should have sorted out before. Yeah, whatever. Rename it. Let's rename it. We'll call scene overlay mobile boarded. and source Osmo boarded. Okay, so in theory I should be able to flip that on and off. Nice. Easy as. Alright, cool. Okay, excellent. Okay, let's actually do some stuff now. What am I gonna do? That is the question. I feel like I should also make this resolution bigger. It sucks for me, but it's probably better for the stream. It's matched. Let's put that. Yeah. Just turn this down to 1920 by 1080 and see what happens. Oh, it's hideous, but yeah, alright. It's probably much better for viewing purposes. Alrighty, okay, let's go. What am I streaming in? Science and technology on YouTube, okay, and coding and software development. Good, alright, let's start at the beginning. Let's do this Raspberry Pi imager. So, what we're going to do here is we're going to install a fresh version of Raspberry Pi Debian Lite. So, what I'm going to do for that is I've got this little doodacky here and got a little 64 gig SD card which I'll chuck in. Boom. Gorgeous. Now, back in the Raspberry Pi imager, we're going to go choose device. I'm coding on this one. I'm doing a Raspberry 4 because reason being, it's got 4 USB ports. It's got more serial imports than the old one. So this has got 5 serial hardware inputs. Perfect for this project and what I want to do with it. So we're going to choose the operating system. Now we are 64. Now there are other general ones. I'm not, unfortunately, as familiar with these. So I think what I'll do later is maybe come back and maybe use something like maybe use something like Alpine Linux or even RISC. I don't know about RISC. It seems fast. Like I mean, we could look it up. We could learn what the dealio. What's the dealio about why you'd want to use RISC? Okay, does Firefox have a dark mode? Because this is assaulting my eyes really badly right now. It's got to have a dark mode, right? And you'd think it's like. There we go. Thank you very much. Remember when things didn't have dark mode? Probably not. And my Windows could be in dark mode as well. Do it. Let's go. Let's go dark. Turn on dark mode. System wired. Oh yeah, that's way cozier. Alright, we're good. Much better. I really like. Oh, this feels so much better on the eyes. Wow. Feels good, man. Alright, next thing we're going to do is search about RISC OS. Operating system designed to run on ARM computers. So, I mean, we could chat GPT it, or grok it, you know. That doesn't seem ring as Google it, does it, you know? Unlock knowledge. Wow, that's what I really want to do. So let's go. We're going to search for... I'm making a hardware MIDI interface with a Raspberry Pi 4. I'm tossing up between using Debian Lite 64-bit and RISC OS. What are the advantages and disadvantages to both? Building hardware with a Raspberry Pi. Yeah, I know it's great. Hardware doing it. Thanks for glazing me up in chat. Choosing between Debian and RISC. Comes down to your priorities. Performance. That's pretty high. Support. That's pretty high. Also pretty high. I'm a bit of a noob. Community. Probably. I mean, I'm a bit of a loner. So and ease of development. Here's a comparative look. Broad software and driver support. Yes. See, this is huge. Actually, I mean, already just reading this one point, I'm gravitating towards it just for the ease of getting the project out. This is the thing. Is making something. Getting it out. And later on, if somebody picks up this project and goes, "Hey, we're going to port this thing to RISC," but for now, maybe I just need to stick with Debian. Familiar Linux environment, familiar-ish. Windows boy. Active community, headless friendly, no desktop environment. System D, service management. Yes. Yes, System D is beautiful. I love it. It's so easy to make boot programs that run in the background and automatically restart if they crash and all sorts of crap with System D, so I like it. I like it over here compared to bare metal OSs. Even Light has more background services than something like RISC. Extremely lightweight and fast boots in seconds. Extremely lightweight and fast boots in seconds. That as well. That is just great. Bare metal performance runs without Linux underneath, close to the hardware. Weird thing to say. Interesting programming environment. BBC Basic. Built in. Old school embedded system feel. I mean, that's kind of cool. Limited MIDI. You need to write low-level code to interface with hardware. I mean, that sounds fun. That does sound like a lot of fun, but I'm not there yet. RISC OS is niche. Yeah, I absolutely agree with this recommendation. So we're going to stick with Debian Lite. That is going to be our jam for now. I know it's not as exciting, not as wild and crazy as going with RISC, but what the hell? Let's do this thing. So we're going to go back into Raspberry Pi OS Other, and we've got Raspberry Pi OS Lite, Debian Bookworm, no desktop environment, compatible with Raspberry 3, 4, that's our boy, and 405. Okay, let's do it. We don't want 32-bit, no need for that, I don't think. See, what's this? Legacy. 64. Screw Legacy, we're going to go with the later one. Okay, we're going to choose storage, which apparently doesn't exist. There it is. What happened there? There it is. Boom. Next. Would you like to apply OS customization settings? Yes, I would. But I don't think that I can show that on stream. So, see, this is the thing. Like, I've got the screen up here. I need to be able to turn that off as well. So I'm going to actually create a thing in Stream Deck, not Steam Deck. I would love a Steam Deck. That'd be kind of cool. Control C, Control V, and we're going to call it main PC, and we're going to what are we going to change it to? PC screens ordered. No, we're just going to go inputs. main scenes, just me. And we're going to do the source, and we're going to go source, PC screens, ordered, and that's going to toggle on and off. So now I should, oh, what did I just do there? Now I should just be able to turn that off. Beautiful. Ah, this is why Stream Deck is a great device. Good old Elgato. Just digging for sponsorships with literally nobody watching. Okay, so let's go back into what we were doing here. What I was doing in private, because not here. You guys cannot see this. Okay, we're gonna call the host name. We're gonna call the host name MidiPunk.local. We're gonna set a username password for the device. We're gonna configure the wireless LAN so we can go headless straight away. We don't need to mess around with anything. This is beautiful. It used to be really difficult to do this on Raspberry Pi. Used to have to go into WA supplicant and the boot partition and stuff, and used to have to edit that to connect to a wireless network. Blah blah blah. You can do it all from the install now, which is just beautiful. Okay, Pacific Auckland locale. I know you guys can't see this if you're watching, but services enable SSH. So that's another important one. I can probably show this actually. Yeah, we're going to enable SSH, and we're going to allow password authentication. Enable SSH, and we're going to allow password authentication in this case. SSH right now. I do need to learn SSH. SSH right now. I do need to learn SSH because I'm lazy. Way better. And then options. We're just going to eject media and finish. I've disabled telemetry. I mean, Raspberry Pi. You know what? Raspberry Pi. Sometimes I just do this out of habit, like, sometimes I don't share my data, but then I think about it, and I'm like, don't share my data, but then I think about it, and I'm like, I'm a software developer, data is really helpful. Data is really helpful and make it better. So, you know, what are they going to get? What are they going to get? You know, what are they going to get? I don't know. And the other thing, I don't know. It doesn't actually say what it does. I think that's what bugs me. That's the most about this. What does the most about this? I'm gonna goggle it. I'm gonna goggle it. I'm gonna goggle it, and we're gonna go. What does use telemetry mean? Raspberry or whatever. Pi. Enable telemetry. Enable telemetry. That's it. Enable. Allows Raspberry Pi Foundation to collect usage data. Allows Raspberry Pi Foundation which operating system is most popular. Such as which operating system is that's not a bad thing, is it? Yeah. See, I mean, that's not a bad thing. Number of times chosen. Storage media used. Number of times chosen. Blah blah blah. Doesn't collect any personal. You know, whatever. You guys can have it. You guys are great. You know, whatever. You guys can have it. Okay. Yes, we would like to apply that, and all existing data is going to be erased. And all existing data is going to be erased. Go for gold. Let's do it. Right. Go for gold. Now, I know this isn't going to take too long. Normally, it's got to download. First, but I've already downloaded it. Should already be in the cache somewhere. We can see the little beeping light there saying, yep. Little beeping light there saying, yep. She's writing. Working. It's good. It's good. Oh, why do I keep closing it too? Why do I keep closing it Windows. I should just minimize it. Okay. I should just minimize now, it. While that's doing that, what we can do is I've got some notes here about the Raspberry Pi. I've got some notes here about the Raspberry Pi, right? So general how-tos, running a program at startup. General how-tos, running a program at startup. Okay, well that's. I actually find. Like with personal knowledge, I actually find that like with personal knowledge management, that storing links is actually not the best. Storing links is actually not the best. Not the best way to do it. Not the best way to do it. I think yeah, storing links ain't a great idea, because what if that link dies, right? I've suddenly lost that knowledge. I mean, in a way, it's like a self-cleansing thing as well, right? The link dies, it's probably because it's unmaintained, old, and maybe irrelevant. So maybe it's not that bad.
So maybe
causes you to look up new information.
Causes you
Anyway,
new information.
So,
Anyway,
MIDI notes on MIDIs. Should put general
MIDI
how to at the top
notes on
there.
MIDIs,
Pinouts and
should put
UART.
general how to at the top there. Pinouts and UART.
Okay, so once we get this pi
once we get
up and
this
running,
pi up and running,
we need to do some configuration.
We need to do some configuration. Some boot configuration.
Remove serial stuff in console.
Remove
so
serial stuff
basically,
in console.
my
So
plan is
basically,
I need to draw. What I need to do is I need to draw a
I
block
need to
diagram.
draw. What I need to do is I
before we
need to draw a
anything else.
block diagram. I think, before we do
Probably
anything else, that's probably pretty important.
Hey, support on the moon. Hey, the voice comes through twice with a bit of delay.
Twice with a bit of delay.
Thank you for letting me know. I appreciate that.
Thank you for letting me know. I appreciate it.
One day I will get this.
One day I will get this.
Now I've got to figure out why.
Now I've got to figure out why.
Now I have to figure out why, which was the fun part. I appreciate you. Yeah, again, I've said that already. I appreciate letting me know.
You letting me know, because
yes.
Yes.
I wonder why that is happening.
I wonder why that is happening.
At my setup here, monitoring device, main aux 3. Okay, that's good.
Okay, that's
Desktop
good.
audio is disabled. All the input devices are disabled.
All the input devices are disabled.
Advanced audio properties. We're going to go. Channel. Main mic. Monitor is off.
Main mic.
NDI main screen.
NDI main screen.
Put that to monitor only. See if that works.
Put that to monitor only.
Might
see
get
if that
a
works.
plot there.
We might get a bit of a double.
Let's bring this over because it's interesting to look at anyway.
Let's bring this over because it's interesting to look at anyway. We can see the
cascade of.
Pretty cascade of.
Sounds like two different mics. Hey,
sounds
you
like
might
two
be
different
something.
mics. Hey, you might be on something. You are
genius. Thank you very much. I appreciate it.
Genius.
It's the first time I've used. It's the first time I've used my Osmo mobile, and that has a mic, and it was coming through on OBS. Thank you very much. I really appreciate your help. Honestly, that. I don't know why. I don't panic, but I'm like, it's always hard to figure stuff out on the fly. So that should sound a lot better now, right? Sound way better. PogChamp, exactly what I thought. Oh, anyway, welcome, support on the moon. How are you doing? What's going on? What sort of stuff are you into? You must be browsing software and in game development for a reason. Watch me struggle through some GoLang. Maybe build a MIDI interface. So yeah, I'm going to configure these UARTs because I has got 5 hardware UARTs versus the 3, and before they only had the 1. This silly little mini UART thing. Just a young programmer interested to see what you're up to. Nice. Oh, well done. Welcome to the world of coding. So, yeah, I mean, I'm an old programmer, I guess. Yeah, I mean, my day job's programming, and I do making and coding for fun in the evenings, basically. So it's pretty much my life. Well, a big part of my life anyway. But I also love music. So this project is supposed to meld the best of both worlds. Basically what I want to build is something like this. So I have a bunch of MIDI devices, like a sampler, a synthesizer. I'm building a big piano thing, 88 key piano controller and all that. All wraps into a suitcase really nicely. And I need a way to connect them all together because I don't want to use a computer for my setup. It's called Dawless, D-A-W less. And so I need a way to route all the MIDI and all the instruments and link them all together and all that sort of stuff. So basically there's these things which exist, and they are really expensive, but they're freaking awesome. And so it's got this little screen on it and stuff like that. So this is basically what I want to build. And so I've got this, if I go back to my mobile thing here, so I've got this little Behringer JT4000, a random frickin' i02W lying around on my bench for some reason. And yeah, Behringer JT4000 little synth, which I'm going to use for testing the USB functionality. I've got a Raspberry Pi 4 Bravo, which I'm setting up currently, and that has got 4 USB inputs and Ethernet, so I can do MIDI over Ethernet. I can do 4 USB MIDI devices like these. Got a little resistive touch screen, which I can interface with, and also a bunch of leftover GPIO pins, general purpose in-out pins, that I can use to, with my breadboard and my limited electronics knowledge, to build a hardware MIDI interface, or 4 of those, which run over the serial ports of my Raspberry Pi. So basically I'll have 4 DIN inputs, 4 DIN inputs, I will have 4 USB inputs, and also MIDI over network by the time I finish with this. So I'm calling it MidiPunk. Going to be a little router box, which looks more like something like that, but probably prettier. That was a lot of talking. Jeepers. Probably left. Yeah, what's this going on about? But anyway, get back into it. What am I doing? Raspberry Pi, continue. That has installed now, so I can now remove the card from the reader. Don't mind if I do. I'm just going to pull off the screen for now. So we just got the beautiful Raspberry Pi board there, and I will way over your head though. Oh, don't worry about that. That's so what sort of coding are you into? Like, what language? What have you done so far? Like, what's your jam? You a vibe coder? Are you into AI coding? To tell you what, as much as there's so much hype around it right now, but like anything, it's a tool, and it can be an incredible tool if used well. But you still need to know. You must know the basics. All right, let's plug this bad boy in. There we go. We've got a red light. We've got a green light, which is good. Oh, and even this little boy started up. That's cool. Okay, beautiful. So what I should be able to do is very shortly open up a terminal, and I should be able to SSH in to this Raspberry Pi without too much hassle. I remember this mobile view that I've got in the top left here. Okay, here we go. SSH MidiPunk.local. Whoops. Local. Oh, right. No, this is the first load, so it actually restarts a couple of times first before I'm able to get in there. So I'll just give it some time. Green light's still flashing, so that means I should wait. It'll shut me up for a couple of seconds. Alright, let's try this now. Okay. MidiPunk. Nope. Still nothing. Oh, it's still loading. Okay. This takes way too long the first time. I've always got to remember. You just give it a bit of time. But what I do wonder though is like if I want to make this into some really nice hardware, I should be able to buy. I wonder if I can buy just the Raspberry Pi. Like, can you buy a Raspberry Pi that's not just for development? Like a production Raspberry Pi. Oh, it's the compute modules. Compute module 4, yes, these bad boys. So you can buy these. Now, the question is, are these still SD card? No, so they've got these funky headers here. Little millipede headers. That's super cool though. And they're so cheap. This is what I need. This is great. Like I need this. But I only need the one with like 1 gig of RAM. It doesn't need much RAM or anything. It doesn't need to be super powerful. Man, the prices jump up really fast. Hey, what's the difference? Like, what's the difference with these? I need to look up I need to look up the friggin' stats. But this might be the way to go, because I mean, $69, nice. That's a good price. And it's only going to come down too. So maybe I should keep the compute module in mind. So I need to do that in my MidiPunk. No, it's the scratch pad. What's this? This is serial stuff. So let's put like serial stuff. And chuck in, what are we going to chuck in there? What are the ideas? Like, to keep in mind. And we'll call this like, Ute module. Nice and small. I wonder if that then interfaces with flash memory through that. I wonder if that interfaces with flash memory via that, or if it's got onboard flash memory. Kinda looks like it's got onboard flash memory. Wi-Fi, Bluetooth, RAM, optional eMMC. I don't remember what that is. Embedded multimedia card. Yeah, right. Okay, so that makes me think that some of these compute modules do have embedded. Yeah, they can get really expensive. I mean, they must be like the 8 gig modules. Oh, stop. I'm not a robot. Creepers, bicycles. What is this? Yeah, bicycle. Alright, verify. Click to feedback. Doesn't really tell me what's going on here. I just need to look up those stats. Anyway, that's beside the point. That's not what I'm trying to do right now. Let's get back into the Pi itself. Can I get in? Yes, I can. Something nasty. That's because I have already... I've been using Linux lately, so... what are we going to do? I should probably turn off main PC for a second while I jump. So let's go note, add, known hosts. Yeah. Bunch of these. That one, save. Probably a good thing I did hide that because it showed a bunch of passwords. I need a real quick switch to do that, like a naughty. I need that Dennis from Jurassic Park meme. That's what I need. So anyway, I should be able to get into this again now. SSH MIDIPunk. Local. What? Still failed. Defending is in no one host 2. Oh, it's probably, you know what? It's probably hashed. Oh, I'm typing ls. No one hosts. For sakes. Reload SSH. Maybe. Oh, there it is. My bad. I was just being blind. See the extra entry in there. SSH MIDIPunk.local. There we go. That's better. Alright, password. And we're in. Okay, so now we need to configure the firmware of the Raspberry Pi. So what I'm going to do is go to boot firmware, and basically we have got config.txt and command line.txt. So I'm going to do command line first because that's kind of that's nice and simple. So we'll go sudo nano cmd line.txt. So we're going to get rid of all these console entries. Oops, because we don't want any console displaying on the any of the displays that we're gonna set up. All right, so we can write that out. Control O, Control X. That's our command line done. So that's tells the Linux kernel where to show stuff and boot and blah blah blah. Alright, next is config.txt. Config. Okay, that is a new file apparently. What? No, it's not. Oh, config.txt. Walkers. Alright, so let's go through this. This is pretty easy. We're not using a camera, so we're just going to turn that off. That's one less service that we need to run. Display auto detect. DSI displays. Now, I'm not using DSI. I can't even remember what DSI stands for. Display serial interface, I think. DSI. Display serial interface. Yes. Good guess. Alright, we are going to turn that off as well. So, automatically load init ramfs files. So, init ramfs is the initial, like, file system that is loaded on the Pi before the proper file system is mounted and everything. And it's what can do things like show a splash screen and, well, so much more. That's really stupid just saying it shows a splash screen, but yeah, all the essential stuff. It's basically like, I guess, the BIOS. Like this config.txt is the Raspberry Pi's basically BIOS configuration. So if we go to Raspberry Pi documentation, yeah, and we've got configuration here, so we go in there, Raspberry config, and we have got command line, we have got boot folder contents. I'm sure there's something about config.txt. Oh, there it is. That's its own bloody section. What is config.txt? Great question. instead of the BIOS, Raspberry Pi uses a configuration file called this. Yeah, that's great. So changes only take effect after reboot. File format, yeah, we got the stuff. Advanced features, don't need that. Auto boot, we don't need to play around with that. Don't need to play around with that. We don't need to do differential booting just yet. So that could come in handy later if I want to do like updates and stuff. Like maybe, I wonder if this is how over-the-air updates and stuff are done. OS a fail-safe OS upgrade. So I wonder if you could like download an upgrade to a different partition and then use this try-boot to load that partition up and attempt an operating system upgrade. And then if it does work, great. If it doesn't work, fall back to the other one. That's cool. We might need to look into that at some for like OTA updates. OTA updates using auto boot.txt, maybe? I don't know. I need to learn more about that. Do that later. Let's go. Common problems. Common display options. We definitely don't need that. So, where was I at? We had DSI displays off. DT overlay. Sort that out soon. This is how we turn all the UART ports on and everything. Device tree configuration. Boost. Yeah, that's fine. Forces PWM on 3.3 volt output from the GP. What? Forces PWM pulse width modulation on 3.3 volt output from the GPIO header or CSI connect. CSI, that's camera serial interface. Anyway. I don't even need that. I just wanted it to make sense in my head, but it still doesn't. So, let's go. Audio, don't need to worry about that yet. Maybe later if I'm doing something to do with audio. HDMI audio output is enabled. To disable HDMI audio output, append no audio to the end of the DT. Okay, I want to do that. I don't want HDMI audio output. So we are going to take that one on board. We're going to add no audio, all as one word. And then we've got start file, fix up file, video core GPU. I don't know anything about that stuff, so I'm not going to touch it at the moment. Kernel, definitely don't want to play around with that stuff right now. ARM 64-bit, yes. I believe that's by default anyway, yep. Disable overscan, that doesn't really matter. Run as fast as firmware allows. ARM boost, yes. Compute module 4 on the go mode. Enable host mode. This line should be removed if the legacy controller is required, e.g. for USB device mode. I think I would need the USB host mode, so I'm just going to leave that on. Not that it matters because I'm not on a compute module. And then we've got an all section, which is where I'm going to add my bits and pieces I need. RAMFS stuff, init RAMFS, and the specifies both the RAMFS file and the memory address to load it. Okay, so that's the thing. If I want a custom splash screen or a custom splash video and all that sort of stuff, that's where I can do it. But for now, I'm not going to. So I'm just going to leave this for now, but we can come back to that. Using the same rules as the kernel selection, that's fine. Disable splash, rainbow splash screen. I don't think we're going to see that anyway. Because, yeah, I don't think we're going to see that anyway, because I don't think the LCD screen is initialized early enough in the process to show the rainbow screen. So I don't think that's going to be a problem for us. Enable UART. Okay. Enable UART equals 1 in conjunction with console equals serial 0 that baud rate in command line.txt requests that the kernel creates a serial console accessible using GPIO pins 14 and 15. Okay. See, I don't need that. I don't need a serial console on any pins because I'm SSHing in. Like I'm not doing crazy old serial SS. Add. Alright, editing command line.txt to remove the line quiet. Enables boot messages from the kernel to appear there. See also UART second stage. God, this is like those choose your own adventure books. It just goes off on this crazy tangents to try and follow these things. I'm not mad. Swear. I'm fine. This is good. This is fine. So enable UART. So I don't know if I want that yet. Actually, I know there's some weird things about UART which we're going to have to read through very carefully to make sure I get the settings right. Force EEPROM read. OS prefix. Multiple versions of the kernel and device tree files. OTG mode. No, I don't need OTG mode. By default, this is enabled on compute module 4. Yeah, we know that. Overlay prefix. No, don't need to change that. Bootload flag. Custom firmware, bare metal firmware. Ooh. Okay. Bit 0 indicates that the ELF file is custom firmware. This disables any compatibility checks. Resets PCIe before starting the... Okay, well, I don't know why I found that so interesting, because... bare metal debug. No, we don't need that either. UART second stage is 1. Then enable debug logging to the UART. No, we don't need that. Erase EEPROM. OS check. Am I still in config.txt? Secure boot, we're not doing that. Program Raspberry Pi boot GPU. JTAG. Oh, this is a lot of skipping over stuff here. GPIO control. Here we go. What does this do? It allows GPIO pins to be set to specific modes and values at boot time in a way that would previously have needed a custom DT device tree blob.bin file. Whatever the heck that is. Each line applies the same settings, or at least makes the same changes to a set of pins, addressing either a single pin, a range of pins, or a comma-separated list. Nice. The pin is set is followed by an equals and one or more comma-separated attributes from them. Right, so we can pull up, pull down, initiate the alternate functions of the pins, drive it high, drive it low, pull it up, pull it down. Oh no, pull up. Wait, drive high? No, pull. So I don't know if I need to do any of this because I have a feeling that just loading the device tree overlays or UART is going to configure the pins anyway. So, yeah, so I don't think I need to touch that right now, but I know the option's there. Overclocking, I'm not even going to look at that. Blocks relationship. The GPU, CPU, SD, RAM, and GPU each have their own PLLs. I can't remember what that stands for. There's so many damn acronyms in technology. What the hell does it mean? Phase locked loop. That's right. The H.264 V3D and ISP blocks share a phase lock loop. Okay, let's have a look at that. I mean, I know roughly what they are, but like, I just want a better understanding of. Can you give me a brief rundown of phase locked loops, PLLs, in computer hardware? Let's go. What is a PLL? Control system that generates an output signal whose phase is related to the phase of an input signal. It locks the frequency of an output clock to a reference clock. Okay, that is fine. So we generate a frequency pulse like via a signal, and then we lock the output to that. For clock generation, clock multiplication, and synchronization, since digital circuits rely on precise timing, PLLs help maintain signal integrity. Clock generation creates high frequency internal clocks from a lower frequency reference clock. Yes, because there's clock multipliers, right? So in your BIOS settings, when you're overclocking, clock multipliers. So it takes that base clock, that lower frequency reference clock, and it multiplies. It keeps it in phase with the base thing, but I guess basically what happens is it like, yeah, does things like generate a faster or slower frequency. So that's cool. Helps in adjusting the clock speed dynamically, like in CPUs with power saving features. Right, that's cool. Okay, so it can still keep the phasing. It can still keep the phasing in phase. But yeah, we can. That's neat. I like it. Phase detector compares input and output clock phases. It phases to stun. I am stunned. Low pass filter smooths out the phase difference signal. Low pass filter. Low pass filter. I always get this around the wrong way. Low pass filter allows low frequency signals passed. So we're looking for a low frequency signal to monitor the phase, not a high frequency. Right. Frequency divider allows output to be a multiple or fraction of the input clock. Yes. Okay. So this is like clock multipliers though. Frequency dividers, whatever. No, I'm good actually by this now, so that makes sense. So basically, yeah, pretty important. To view the Raspberry Pi's current frequency, type scaling current frequency. Divide the result by 1,000 to divide the value of megahertz. Note that this frequency is like the kernel requested frequency, and it's possible that any throttling may mean the CPU is actually running more slowly than reported. Okay, an instantaneous measurement. Yeah, right. Well, it didn't really tell me a lot, but I learned something, so that's cool. Monitoring voltage above 4.8 for reliable. Note that voltage from some USB chargers power supplies can fall as low as 4.2. Yes, indeed they can. I had that issue the other day when playing around with some stuff. Not supply 5 volts for a computer. You will need to use a multimeter to measure between VCC and ground. Cores will be throttled back. Message low voltage state. Yeah, I've seen that in the GUI before. Right, the all filter. Here we go. And we've got model filters. That's cool. View module. Also sees Pi4 contents. These are particularly useful for defining different kernel, init RAM FS, and command line settings. Yeah, that does make sense actually. Dealing with different hardware, the none filter prevents any settings that follow from being applied to any hardware. Ah, interesting. Although there is nothing you can't do without none, it can be a useful way to keep groups of unused settings without having to comment out every line. Okay. The try boot, yeah, EDID, we don't need that. Serial number. Oh, wow, okay. Apply to an individual specific Raspberry Pi. License keys and overclocking setting. Wow, okay. Yeah. That's kind of... Not that I need that, because this is going to be open source software, so... the GPIO filter... This is cool. I love this. Alright, so I'm going to take a note on this. We're going to go... GPIO filter settings in config.txt for things like alternate mix, etc. So maybe like even to configure this MIDI router, like you'd start it up by holding down a... Oh, that sounds stupid. Would you want to do that? Maybe like to reset it, you could reset it, factory firmware reset, like we can hold down the button while we're starting up. Factory settings. I mean, again, you could do that through the menu, but you wouldn't want to do that by accident. Maybe button is a good thing. I don't know, we'll think about it. Anyway, memory options. Maybe you don't want the screen. Maybe you want it running without the screen. That might be a good option too. Be running without the screen. Oh, yeah. Command line. Wow, I feel like did I just like... Yeah, I did. MPEG-2 license key. That. Composite video, TV out. And there's a lot of settings in here. Okay, here we go. This looks interesting. Ignore LCD. By default, the Raspberry Pi touch display is used when detected on the I2C bus. I don't think this screen, I don't think this little bad boy here, this isn't I2C. This is SPI, Serial Peripheral Interface. So, ignore LCD equals 1, I think I actually want. Let's try it. I'll know which commands are mine because they're all at the bottom. So, we'll go ignore LCD equals 1. We're also going to go disable touch screen. Official Raspberry Pi touch display. Well, you see, I don't have one of those. So, disable touch screen equals 1. Okay, disable firmware kernel mode system stuff. It's an appropriate video mode, then passes the resolution frame rate to the Linux kernel via setting. I don't know. Don't need that. Disable camera LED. Auto white balance. Auto is grey world. Capture valid images and videos with no IR filter. Oh, that's no infrared on the camera. Oh, yeah. Okay. Well, I think as far as the config.txt help, we've read through the whole damn thing. So I think we're good there. What else have we got? Configuration. Displays. Raindrop. Screen configuration. What the hell is raindrop? I don't know. Well, let's write this out. Let's get out of here and we'll go sudo apt install. I probably need to go apt get update. Get update. Apt. What's the difference between apt and apt get? Newer, more user-friendly. Oh. More streamlined, intuitive interface. I like that. Okay, I'm going to use apt. Let's go. So we're going to go apt install raindrop. Unable to acquire the yep, it's because sudo. 103 megabytes. Holy moly, bananas. Holy bananas. Banana. Anyway, random shit sometimes. I don't know where I'm going with it. Pretty lonely in here without any viewers. I like my other channel. I want to improve my mobile color filter. This looks terrible. So let's do that. To do that, I have to go to studio mode. Actually, I don't have to go to studio. Yeah, I should. In Osmo Stream, Osmo Pocket. We're going to go filters. We're going to go video filters. And we're going to do some color correction. Maybe it's fixed. Yeah, color correction. See if we can make this look any better. Gamma. A little bit more contrasty. That's good. Gamma, we'll bring up like maybe the smallest amount of saturation. Probably still too much. Hue shift is fine, opacity's good. Contrast. There's a bit of high contrast there between the blacks. Brights. What I need is a histogram so I can actually see what... Okay, let's compare that to the... Yeah, it's a bit better. A bit better. I feel like I haven't gone far enough with it, you know? Look at that. That looks nice. Hue shift. Brightness. Whoa, no. Not touching the brightness. Okay, we'll leave it there. I think that looks cool. Alright, let's go back. Alright. Stuff. Rightio. Let's move on. We are now going to try raindrop. Cannot open display. Makes sense. I don't have any displays. AMS print. Okay, so this is just talking about HDMI connectors. Right. Did a custom rotation, console resolution, audio, networking. Don't need to worry about any of that. Wireless. Okay, where am I at? Where am I at here? Networking, screen blanking. Uses external storage, kernel command line. Here we go. So I've removed those already. Why? I want that as well. Okay, so we're going to go sudo nano cmd line.txt, and we're going to put the quiet flag in there because we don't want it making noise. Yeah, we're using X4 for our file system. AMS display mode. Kernel mode setting, that's right. If no video entry is present. Raspberry Pi uses the EDID of the HDMI connected monitor. Okay, well I haven't got any. I haven't got any. Possible options for the display type. The first part of the video entry include HDMI. So, I mean, what I could do actually is I could set the resolution, because something I know here, I'm using the, okay, to render graphics, I'm going to be using the frame buffer. So, drawing pixels to the frame buffer, which then gets rendered out to the screens. Now, the frame buffer on the HDMI is hardware accelerated, and I know I can copy that frame buffer to the LCD screen. So I can have hardware acceleration, and I can have, yeah, I can have that, and I can have it applied on the LCD screen. So, I can't remember what the resolution of the damn thing is. I think it's 320 by 280. Pretty sure it is. So let's go Raspberry Pi 2.8 ITFT 28 320 by 240. Is that what I said? Doesn't matter. Okay, so we're gonna I need to see what I'm doing, because I think I'm hiding half of my crap behind this mobile view. Maybe I can just turn that off for now. I don't need it. Right? Okay, now we're going to go and copy that. We're going to take the video, paste that in there, read one line. Try that again. Huh? Yeah, okay, so paste doesn't work that way. You know. Okay, let's go video equals HDMI A1, and we're going to go 320 by 240. M. What is M? Linux frame buffer documentation. M or R? R is specified to reduced blanking. The timings will be calculated using Visa coordinated video timings. We're looking up the mode from the table. I don't know, I'm just gonna put M in there because, and we're gonna go M at 25. Let's make it 25 FPS. No, we'll make it 20 FPS actually. Start. Keep it simple. Write that out. Back here, we are going to go other entries. Tells the boot to use the splash via the Plymouth module. I do want that, but I don't think it's actually going to work because of that whole deal about the LCD display being emitted too late. Plymouth ignore serial console. Normally, if the Plymouth module is enabled, it will prevent boot messages from appearing on any serial console which may be present. That's a good thing. That's what I want. This flag tells Plymouth to ignore those, making boot messages visible. Nah, I don't want that, you see. That's actually not what I want. Link power management, which drives the USB controller built into the processor. This controller is disabled by default and is only connected to the USB Type-C. The USB-A ports on the Pi are driven by a separate controller, which is connected by the... Okay, well that sounds good. Mouse polling, we don't need that. Localized, secure. Holy moly. Set up a headless Raspberry Pi. I've already done that. Pretty much. Host that. We don't need that. We don't need a proxy server. Okay, boot folder content. What do we got going on here? Boot files on the first partition of the SD. So write that out. Let's quit. How do you... Is it disk... No, disk parts Windows, isn't it? How do you view partitions in Linux? Not DU? That's disk usage, eh? What's DF? Free space. I'm sure there's a command for that. Linux partition. I don't know Linux at all. Partition. We use the command N. Oh, wait. It's not an actual command. Start the partitioning tool. Can fdisk? List. Yeah, there we go. See, FAT32. Start end. MMC block 0, partition 1. Yeah, now it's not the boot partition, is it? Because... Oh, this is strange. All this. RAM. All our different devices. Oh, that's just the devices. Okay, and then on that device we've got the partitions. That makes sense. Okay, my bad. So we've got the partition one, 512 megabytes, and that is yeah, MMC block 0, partition 1 and 2. Okay. The only reason I'm looking at this is because I just want to learn more about how it is structured. And it's interesting that the boot partition isn't that. I don't know. Yeah. Firmware 65 megabytes. Not making a lot of sense, is it? Oh, maybe I've got to like do it recursively. So du. How do you do recursive? Depth. All. Minus A. Must be. Oh, yeah. Right. Well, that didn't tell me anything. Okay, I'm wasting time doing this. Ridiculous. Okay. I'm not too worried about wasting time because no one's here, so fine. Me talking to my own lonesome at the moment. DRM drivers. Maybe I need some coding music. Maybe I need some intense coding music. Oh. Oh, I don't even know where all my windows are. Like, Restreamer and one more. There it is. Okay. Goodbye 12 hours of copyright-free music. Hello, programming music. Deep work music for programmers. Chill step and future garage mix.
Empower your students to be more authentic.
No, not Grammarly ad.
With Grammarly's
Oh,
comprehensive AI
God.
writing assistance. Use it to help.
Not intense enough. What about this? Still not quite right, but whatever, I'll leave this going. Okay, we are going to now go. Nice synth arpeggiation going on here. What is the visa coordinate video times? Yada yada yada. Blah blah blah. I'm in the wrong doc. Okay. Art elf. Yeah, we've already had a look at all this stuff. Issue. Init RAMFS. Loads a temporary root file system into memory before the real root file system can be counted. Raspberry Pi OS includes an init RAMFS by default. To enable it, configure it in config with the auto init RAMFS, which is what we did. We did that already, so that's good. SSH boot, which we've got. Device tree blob files. Kernel image overlays folder. This is where we're getting next, is overlays. We need to enable some of these. Configure UARTs. Here we go. Right, this is going to be fun. Is it going to be fun? We will see. Alright, there are two types. PL011s and mini UARTs. And I want PL011s. 16550 compatible UART, while the mini UART has a reduced feature set. All UARTs are 3.3 volts. Now that's super important for our circuit design, because we could easily blow up the Pi if we don't, you know. If we don't allow for that, does look a bit better actually. That color grading. Yeah. So what we need to do is the Pi is 3.3 volts, but the problem is our MIDI is 5 volts. So this prototype circuit here that I've got going, which we'll look at on the oscilloscope soon, that's what's going to step down our 5 volt logic level down to 3.3 volt logic level, so we don't fry our Pi. Frying pies, you're in for a surprise. Don't do it. Just don't. Okay, Raspberry Pi 0, 1, 2, and 3. That's not us. Pi 4 and 400. here we go. Now I've already got notes about this. Already got notes. And that is down in Raspberry Pi pinouts and UART. So let's see if everything's up to date. Pi 4B. Okay, I've done this nice little table here, which summarizes it all for me. I don't need this CTS and RTS. I can't even remember what that is. CTS, RTS, UART. Request to send, clear to send. These wires are cross-coupled between the two, so RTS on one device. Right, yeah, okay. So that's turning off its... That makes sense, managing the data flow. Okay, so we obviously don't need data flow management here. Writing a handshaking mechanism. That's pretty clever, but we don't need that for MIDI. MIDI doesn't use CTS and RTS. MIDI is just MIDI in and MIDI out, so... Yeah. Alright. So I'm actually going to... I kind of want to get rid of that, but it'll disrupt my notes. I'll leave it there for now. Okay, let's have a look at this. UART 0. So in this case, UART 1 is the mini UART. So I kind of want to highlight this and make a big deal out of it because it is... Is there a way you can like color text in this? I don't think there is, eh? That's one of this. I love Obsidian, but it does have some real downsides and some things that I think should just be in, like, you shouldn't need to download plugins for. It should just be in the core. For any note taking. I don't know. Anyway, I've highlighted that apparently. Maybe you can't highlight code. What's another way I can bring attention to that? I should have just done this in a table. That makes sense, doesn't it? Let's do that. Like, why not? Jeez. So UART, we're going to go TXD, RXD, CTS, RTS, header pin, receive, header pin, no, header pin transmit, header pin receive, pipe, use. Header in RX. Oh, we'll just go pin TX. I think pin RX. That's the GPIO numbers. CT clear to send. What does RTS stand for again? Request to send. Right, okay, that makes sense. One device goes, hey, am I good to send? And then that device lights up and goes clear to send. Okay, blah, 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 blah. Does its thing. That's good. Alright, you are 0, 14, 15. No. No. Header pin, 8, 10. It's a plol. And use is secondary, secondary slash Bluetooth. UART 1 is also 14 and 15. That has no clear to send, request to send. And pin TX is 8 and 10. It's basically the same. But this is mini UART, the limited version. And this is our primary slash console UART port. Now we've got 2. We go 0, 1, 2, 3. Oh, that's okay. Why did I not see that pattern before? Anyway, whatever. So 27, whoops, 27, 28. I2C 0. I2 0. I should note that they're in the use because that's what we're going to be stepping on as I2C communication if we use that. 4, 5, 6, 7. That's 7 and 29. And that is got no other uses there. UART 4, we've got 8, 9, 10, 11. And the header pins are 24 and 21. There's no type. Oh, actually, type I can chuck in there, can't I? See, PL011, PL011, and PL011. And then we've got that is PI0. So basically on this one, because the LCD screen uses SPI, we cannot use UART 4, where, yeah, 12, 13, 14, 15. NTX 32, 33, and that's PL011, and that's UPIO ban. So that must be PWM. There's no way, like, we can't color this, can we? Wish you could. I don't know. Maybe, you know, maybe I do have to download a freaking plugin to be able to color my text. Whatever. Okay, we are just going to put a star next to this one, because that is how we are going to. That is. It's quite important. Mini UART. Okie dokie then. Now we have got that. I can get rid of this. Old one. And there we go. We've got a nice table reference there. Okay, let's go down. Compute modules. Primary. On all models of compute module, the UARTs are disabled by default and can be explicitly enabled using a device tree overlay. You may also specify which GPIO pins to use. For example, UART 1. I wonder if that applies to all UARTs though. Like, can you specify the pins on each one? Because I think there's a way here if we go DT overlay help. DT overlay -H, where overlay is the name of an overlay or param. So we can go UART 2. Yeah, so this only lets us enable or disable CTS RTS, but there's no other parameters on GPIOs 0 to 3. So what about UART 1? Yeah, TXD or RXD pin, so I can change the pins on that, which I probably want to take a note of as well. So this is UART 1, which is a mini UART. What about UART 0? Oh shit, okay. So I can change the pins on UART 0 as well. Interesting. 14, 32, or 36. 14, 32, or 36. 15, 33, or 37. $37. Yeah, cool. So we can use pin funk. Parameter or UART 0. So we can use pin function equals X. Which gives us an alternative pin function oh my goodness. This is ridiculous. Okay. That. Maybe we'll go alternative pin function param UART 0 pin func equals X, where X equals that. Okay, that's a good note. So I can easily change the pin numbers of that UART. Okay, that's fantastic. I like it. Alrighty. Moving right along. Where were we up to? Primary UART. On the Raspberry Pi, one UART is selected to be present on GPIO 14 and 15. This is the primary UART. By default, this will also be the UART on which a serial console may be present, but we did turn that off when we nanoed the hell out of sudo nano what was it, config on big.txt. We did the thing where we said no, wait, we haven't put enable UART in here at all. Okay, let's keep reading. Secondary UART. The secondary UART is not normally present on the GPIO connector. Okay, by default, the secondary UART is connected to the Bluetooth side of the combined wireless LAN Bluetooth controller. That's us. So that's that. That's the secondary controller. The following table summarizes them. So ours is Raspberry Pi 4. Primary console is UART 1, which we know. That's mini UART primary console. Secondary Bluetooth is UART 0, which is PLO11, which makes sense. You'd want the Bluetooth on a hardware controlled or on a full featured UART port. That does make sense that the Bluetooth is on. TTYS0 device. Okay, so we're going to add in one more column here, and we're going to call it device flag. So that is going to be TTYAMA0, and that is going to be TTYS0. And then these are just going to be like counting up. 5, 4, 3. Maybe I got that wrong. Crap. 1, 2, 3, 4. TTYMA 4. Is that right? Gotta be. Maybe not. Maybe it's the same as UART 5. Oh, I don't bloody know. We'll see when we load them up anyway. Is there no TTYAMA 1? Maybe not on the Pi 4. Okay. Div serial 0 and serial 1 are symbolic links. Alright. Due to changes in Bookworm, serial 1 does not exist by default. Re-enable serial 1. I don't really need it. Like, why would I want a symbolic link when I've just got the devices? I don't need the symbolic link. This option may not work in the future. Yeah, alright. Good. Mini UART and CPU core. The mini UART is disabled by default if it is the primary. If it is the primary, which it's not. Wait, yes it is. What? Hang on. What the hell? This doesn't make any sense. Mini UART is disabled by default. Oh, okay, so this is actually disabled by default. Yeah, that's what we do, isn't it? Okay, so, okay. So that's like a good thing. That's actually disabled. In order to use the mini UART, which I don't want to use, I'm going to say I don't want to use that. You need to configure the Raspberry Pi to use a fixed VPU core. Virtual processing unit. Right. This is because the mini UART is linked to the VPU core clock. Okay. Well, alright, so you can like... Yeah, okay. So that when the core clock frequency changes, the UART baud rate will also change. Right, so you can do weird baud rates like MIDI's non-standard 31250. Wait. Is that right? Yeah, 31.25. The enable UART and core frequency settings can be added to config text to change the behavior of the mini UART. The following table summarizes the possible combinations. So let's have a look. Mini UART set to primary. Core clock variable. Mini UART disabled. Now I have not specified a core clock, and as far as I'm aware, because I'm on a Raspberry Pi 4, this is my situation right now. Mini UART's disabled. Okay. Mini UART is the primary. Yes, Raspberry Pi 4. Fixed by setting enable UART to 1. The result is that, so if we set that value in config.txt, what we're going to see is the mini UART is enabled. The mini UART's enabled. The core clock is fixed to 250. No, so I don't want that. I don't want none of that crap. Not what I need. Secondary UART. Oh, I don't know how you set the mini UART to secondary. If it is the primary or when Bluetooth is. Why does Bluetooth change whether the mini UART is that on a different device? Like if I go back up here, oh, it's for the Raspberry Pi 1, 2, and 3. Gotcha. Gotcha. So on these devices, UART 1 is a mini UART, and the Bluetooth operates on UART 1. Okay. Alright. Making sense. This is good. Oh. Alright. The primary UART is the mini UART in our case. This is us. Raspberry Pi 4. Primary is mini UART. Default state of enable UART is 0. So this is our default state right here, which is what I want. After all of that, I've decided, okay, after all of that, I've figured out that that is the case. All right. Disabling the Linux serial console. Yes, I need to do this. By default, the primary UART is assigned to the Linux console. I do not want that, and I'm pretty sure I changed that in command line.txt. If you want to use the primary UART for other purposes, well, I don't, but you must reconfigure. It's going to be done with Raspberry OS. I don't think it's going to hurt if I do this. So if I go out of here and I go sudo raspberry config, and we go select option 3 interface options, and we go option 6 serial port. Would you like a login shell to be accessible over serial? Yeah, okay, so it's saying no anyway, so I think that's... Oh. Would you like the serial hardware port? Serial port hardware to be enabled. I mean, yes, but is this talking about... the primary UART for other purposes? But I don't want to use the primary UART for other purposes. I want to use the secondary one. So I'm just going to say no for now. I'm not going to change anything. Serial interface is disabled. Okay. Good. So that will be that enabled UART setting, alright? So that's still going to be 0, which is what I want. So we're going to go finish that. Let's just have a look in devices. And we've got TTY. We don't have TTY S0, which is good because that's the mini UART, and we don't have any TTY AMAs either. So that means none of the other UART ports are enabled as well. UART 0, 2, 3, 4, and 5. Okay. Oh man, this is crazy. Early console, we don't need that. UARTs and device tree. Here we go. The kernel GitHub. Two most useful overlays are disable BT. I think we want that. Disable Bluetooth. Hey, no, because there is MIDI Bluetooth. But there are Bluetooth MIDI devices. Do I want to deal with that though? I don't think I do. I don't think I do right now. Think about network MIDI. DIN and USB are the first two things that I really have to focus on. Let's stay there. Various yada yada yada. Okay, so let's have a look at this. Where do you find them? Device overlays. Linux kernel. Is this Raspberry Pi's this is Raspberry Pi's fork basically of the Linux kernel, or the Linux kernel compiled? Oh no, there's old Linus. Righto. Let's go. Yeah, you can get the hell out of here, bot. Bye. Alrighty. Kernel. modules. But where do we find the overlays? Oh, that's crazy, eh? Linux kernel. Wild. Absolutely wild. Okay, anyway, so where would you find the device tree overlays? Tools? Nah, it wouldn't be tools. Firmware? Maybe. Nah. I have no freaking idea. Can you even search? What about scripts? Modules. Oh, I don't freaking know. Let's... Can I just search? Let's search. Let's go UART 2. Arch, arm, boot. Not in the kernel. So why did it tell me to go to the freaking kernel? What's up with that? Weird. Okay. Linux. Oh, it isn't there. Arch, boot, DTS, device trees over. UART 2 overlay. Yeah, okay. Alright then. Fine. Is this going to tell me anything interesting or not? Probably not. Using overlays. I know how to do that. It's easy. So you just edit. DT overlay equals blah blah blah. Okay, here we go. Let's see if we can find UART. UART. UART set to on or off. Default varies. Set to off to disable. UART 0. Okay. Looks like there's more details down here, so let's go down to UART ALE. Oh, MIDI? Did I see MIDI? I did. Overlay. Oh, MIPI. MIPI. Oh, there is MIDI though. MIDI UART. Here we go. Configures UART 4 so that the requested 38.4 kilobaud actually gets 31.25. The frequency required for MIDI. So that then is probably doing that thing of adjusting the clock frequency somehow. I don't know if the PL 011s have their own little clock in them that can be adjusted. Maybe they do. Well, let's have a look. Let's have a look at the code. Let's go MIDI UART 4. HIL. MIDI UART 4 overlay. Make a higher clock rate. The real clock's 48 megahertz. So that's 48 megahertz of the serial hardware itself, probably. Which will scale so they're requesting 38.4. Oh, yeah. Okay. Look at that. Compatible. So where do they set that? Clock frequency. UART clock output names MIDI clock. So we're defining MIDI clock compatible with fixed clocks. I don't know what the syntax of this device tree overlay stuff is. This is wild. Target UART for overlay clocks. Okay, so yeah, this is setting the clocks. Broadcom 2835 clock VP. Interesting. Yeah, that's a little bit over my head, but that's okay. There are other UARTs. Alright, let's have a look at this. Various UART devices disable BT, disables Bluetooth, and makes the first PL011 the primary UART. I think that's what I want to do. In my battery. That's way more difficult. See? Alrighty. Back into that's disable BT. Alright, that's what I want to do. So we're going to go back to boot, firmware, and we're going to go sudo nano config.txt, and we're going to go down to the bottom here, and we're going to enable UART 0. So that wasn't there before. So Raspberry config has added that. So we're going to add in here disable BT equals 1. Now there's another note here that we need sudo system CTL disable HCI UART. Interesting. Okay, so let's do that then. Let's go. What is it? Sudo system CTL disable HCI UART. Do I need .service on the end? Oh. I mean, it probably wouldn't have hurt. Alright, remove that. Good, that's good. And we've got to decide which UARTs we can actually use here. So what I need is I need to compare the UART ins with the ins that the Pi TFT needs. So I need a solid reference for the Pi TFT 28. And out. The design uses the hardware SPI pins. Block, mostly MISO, CE01 and C1, as well as GPIO 24 and 25. All other GPIO pins are unused. So, is this going to tell me anything if I go into this? Yeah, so that looks like it's got the same header. It's exactly the same. This is a cheap knockoff clone that I've got, but it is precisely the same. So, yeah, that's good, because I can kind of trust that it uses the same pins in that case. So what is this document? This is a huge document. ITFT is a raw frame buffer device. Actually, this document might actually be freaking pretty good. Using frame buffer copy. Okay. Well, this is cool. This is a good document, actually. No shit. Can it play Doom? Yes, it can. I mean, that's Quake. Actually, is it Quake? Yeah, it's Quake, isn't it? Quake 3 Arena. Oh my god, I love Quake 3 Arena. That game was bomb. That was, oh shit. Okay. Where small composite screens require some video scaling. Our latest PyTFT drivers, along with a cool tool called Frame Buffer Copy. Careful system configuration and optionally the more potent Raspberry Pi 2 board. Open doors. Yeah, cool. Okay, let's queue that up. Backlight control. The PyTFT uses a boost converter. Interesting. So that'd be quite noisy, right? Screen and touch plate will still work. You just can't see anything. We designed the board. Blah blah blah. EWM backlight control. And disabling backlight control. Huh. On and off using STMP GPIO. Oh, no shit. Well, that's cool. I think that this document here is brilliant. I think we need to use this because this should solve all of our problems in one. Great. It's pretty old though. Anyway, ITFT's raw frame buffer device. Raw frame buffer device. Text console, raw frame buffer. Comfortable using frame buffer devices. Both be active. HDMI will be active on Pi. ITFT is black. FPI for displaying images. Rated. Yeah, so this is where frame buffer copy comes in, and we have the IGR. Okay, well, we'll come back to that later, because that's going to be really important. Anyway, so let's enable these UARTs. Let's figure out what the pinouts are on. So, does this have... I wanted to know the hardware pinouts. Displaying images. Using frame buffer copy, extras, gesture input, downloads, Pi 2.8 plus schematic and layout. There we go. For the Pi version 2x20 header. This is good. This is what we want. Original Pi. No, this is the original. This is exactly the one that's... This is exactly the design I have. 2x13 header. So what do I have here? Do I have 13? I do, I think. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13. I do. 26 pin. Probably just resolder it like itself, but okay. Jumper. It seems like a lot of these are a lot of these actually not connected, and why is this so low resolution? What the heck? Oh, I'm gonna download this. Yeah. And we'll open her up. Want to open it? Something else. Open with... I need an Acrobat Reader or something. I hate to say. Okay, well that's exactly the same. I've just loaded it from a local file system. Great. Let's go schematics. Enhance. Damn you. Oh, come on. Okay, I mean, so this is the same. Really, all I need is the bottom one. So maybe I'll just take a crappy screenshot. Was it the most clear about there, eh? See if it matches up with what I've already got. I'm sure I started doing a drawing. No. I'm sure I had a drawing going. Did it end up somewhere weird? Ramp. Drag this off screen for a second if I'm going in here. I'm going raw. What are we doing? How the hell do I do this again? Files. There we go. Explore. I want this drawing. Oh, Excalidraw. I thought I had a second window open with that though. You're not. Dreaming. Oh, I need a drink. I need caffeine or something. Keep me out. Keep going. I bloody knew it. I knew I had it somewhere. I knew I did. Okay, let's see if this matches up with that. So, oh, it's upside down. Of course it is. Start. Let's grab this and we will go flipsies. Even that's, oh, that's so annoying. Okay, how about then, how about I do this? Take that, and we go in here and we copy it, and we can, now how are we going to match this up? We're going to go like that, and this is only for comparing and making sure we got this right, and then we'll flip it over. Okay, so, oh my gosh. So annoying. 3.3 volts. Okay, ground. S clock. Miso. Mosi. Nothing. GPIO. Is that 22? And 21. GPIO 22 and 21. Okay. Stupidest way to do this in the world, but I'm going to persist because I'm like that. GPIO 22. Okay. GPIO 21. Cool. Alright, when we keep moving down the board, we got nothing. We got ground. We've got GPIO 4 apparently, which is actually not like used or something. I don't know. SCL SDA. Okay, so maybe we do need those. Oh, that's annoying. If we do. Oh no, that doesn't make sense. Hang on a minute. No, because that's on the inside. Okay, so we don't need those. We don't need those at all. We got 3.3 volts. Cool. 3.3 volts is good. Plus 5. Plus 5, we've got ground. That's good on the third pin. And then we've got blank. GPIO 18. So why is that? Is that actually hooked up to something? Okay. GPIO. We got ground. TXD, RXD. GPIO 18. Okay. And then ground 23. All right. RT int. I don't know what that means. So we've got CE1, which is SPI. CE0, which is also part of the SPI thing for the LCD. That's touch. And then we've got GPIO 25. There. GPIO 25. I feel like I need a break and I need to do some art. I need to do some pixel art for character. The character for this, the logo. Need to go get a drink. Alright, so just looking at these connections here, let's have a look and see what it, like, restricts us to in terms of what UARTs we can use. So, we got this pinouts and UART thing here. Alright, so let's see. So, listing them out, we've got GPIO 21, 22, 23, 25, and 18. So here we've got these are the GPIO pins then? They are, aren't they? This might actually work out beautifully because all the pins are actually up really high, like except for number 7, but we don't use number 7. GPIO 4 is, yeah, stuck in the middle of ground, and yeah, okay, so that might actually work out alright. These are all up above the header, sort of. They're not actually. They're not used by. I can probably turn this back around again now, can't I? And flip it. Flip it and spin it and blah blah blah. There we go. Right. 21, 2, 3, 4. Okay, so yeah, we are stepping on some of these things, aren't we? So I think I already knew that. I think I already knew I couldn't use UART 4, so that one's out of the question. So UART 4 is gone, burgers. We cannot use that because that's SPI 0 and we need SPI. Yeah, so unfortunately that one's gone. 27 and 28 are fine. That's right next door to that's UART 2. UART 3 is pin number 7, which is not used. That's GPIO 4. And pin number 29, which is off the top of this again as well. It's the next group, 29. And then we've got 32 and 33. So it looks like, oh, what about 8 and 10? 8 and 10 are free as well. So we can use UART 0. So let's go back into our notes here. So we have got 0 stuff. We can use UARTs 0, 2, 3, and 5 without interfering with any of the LCD pins. Cool. Nice, it's good to know. Bloody brilliant, actually. That's excellent. Excellent, yep. So, these ones here, what did I note those down for? Are they actually needed to be used? This whole thing. Don't scratch. I'm getting all my notes disorganized and all over the place here. So pinouts and there we go. Let's go to let's double check this again. Alright. Oh, we can change these to different pins if we want to. The 32 and 33 or 36 and 37. So if we figure out where those pins are, we'll reopen pinouts and UART here, and 33. Wait. Alt. 15. 32. That doesn't make any sense. There's no GPIO 32. These must be pin numbers. So, what? Alt 0. This doesn't make any sense. 14 and 15. That's referring to GPIO numbers, isn't it? Oh, I don't know. We gotta look at the frickin' pulp again for the thing. So let's save, let's quit, let's go. Was it DT overlay /H UART 0? Alternative in function. But it's not pins 14 and 15, or is it actually? Am I getting baited here? That no, because the pins are 8. This is incredibly. Oh my gosh. Okay, so there is no 30. All right, so it must be referring to pin numbers. Maybe it's referring to no, I don't even know. 1, 2, 3, 4, 5, 6, 7, 8, 9. What? 8 and 10. Huh? 1, 2, 3, 4, 5, 7, 8, 10. Makes sense. Pin 1 is 3.3 volts. But yeah, I have absolutely no idea what 32 and 36 are talking about. That might be the Broadcom pin numbers, which I did have some sort of reference for that somewhere. I did have some kind of weird picture about the Broadcom pin numbers. So confusing. Let's have a look and see if we can find it. Raspberry Pi. Let's go. Raspberry Pi Broadcom pins. GPIO Broadcom pin. Okay, so see what I want to find is Broadcom pin friggin' 30 something or other. Physical board pin 30. This makes absolutely no sense. alternative pin function for GPIO pin 32 or 36. Where is pin 32 and 36 on a Raspberry Pi? Is it like not actually available on the header? GPIO Raspberry Pi. Let's have a look. Raspberry Pi GPIO. 32. And not exposed on Pi 4. Yeah, okay, here we freaking go. And not exposed on Pi 4 or any other normal Pi as they are used for internal functions, e.g. camera, DSI, display control, SD controller. They're exposed on Compute Module 1 and 3, largely not on Compute Module 4, as there are more internal functions. Right, okay, that makes a lot of sense. Alright, that finally makes sense. But pins greater than 25 are only exposed on the compute modules. Okay, so that doesn't actually help me at all, so we've got to use 8 and 10. Fair enough. God, that was painful. Rightio then. Good luck on finding a solution. It sounds real like sarcastic, hey? Good luck on finding a solution to your problem. I know it's probably not meant that way, but okay. Well, now we've sorted that out. Let's move on. I need to find a place to store this document as well. So I'm going to pop that in my electronics reference material. Electronics, and we're going to call it Raspberry Pi. Wait, what was it? It was the Raspberry Pi General. Yep. Now let's see. Get rid of that. Get rid of that. We're in the middle of configuring these UARTs. So we've disabled Bluetooth. Let's get back into sudo nano config.txt. Let's get back into here. We've got frame buffers 2. Frame buffers 2 makes sense actually because we've got 2 HDMI ports. So now enable UART 0, disable Bluetooth is 1, and we decided that so does that mean that having disabled Bluetooth, I don't need to include the UART 0 overlay? I mean, maybe I don't. Okay, right. And the other UARTs that I needed were 2, 3, and 5. So we're going to go device tree overlay equals UART 2, DT overlay equals UART 3, DT overlay equals UART 5. Right, now we shouldn't be stepping on any of the display things. Now there were the other ones as well. We want to enable the UARTs, but we also want to enable MIDI UARTs on these ports as well. So we're going to go DT overlay equals MIDI UART 0. A quick way to cut 0, 2, 3, 5. 0, 2, 3, 5. Okay. Save that. Cool. Yeah, okay, I know what device trees are, that's all good. So this is talking about, is this talking about building your own freaking device trees? Crazy. Change the default pin configuration. Custom default pin configurations via user provided device tree blobs. Okay, well, definitely not doing that. The GPIO pins go through various actions. Power on. Setting by the boot ROM, setting by boot code, setting by DT blob, setting by the GPIO command, then config.txt. Additional firmware. Default pulls are only applied on a power on reset. Right, okay. Whoa, right, my neck. I think I need to stand up and go get a drink. So I don't think I necessarily need any of this stuff at the moment. This is going a bit far. GPIO pads. Roll. What's that? I don't know. Industrial use. Often used as part of another product. You go, there's all these old school, like, electrical engineers and stuff going, no, you don't use a Raspberry Pi. I get where they're coming from. Yeah, I get it. Read and write customer on programmable values. That's kind of cool. All Raspberry Pi single board computers have an inbuilt area of one-time programmable memory, which is actually a part of the main system on chip. As its name implies, OTP memory can be written to only once. Wow. Talk about pressure. Once a bit has been changed to 1, it can never be returned to 0. Each bit is a fuse. Programming it involves deliberately blowing the fuse. Irreversible process. Whoa, that's awesome. I actually really, that's kind of cool. Like, there are a number of OTP values that can be used. To see a list of them, run the following command. Serial number, one's complement, and board revision number. Also from 36 to 43 inclusive, there are 8 rows of 32 bits available for the customer on BCM 2712 devices. I can't remember what the Raspberry Pi 4 is. Yeah, this is crazy. I love it. I love it. Wait, so you have to lock them? I thought it said once you've set them, you can't... You can't undo them. So what's the point of... What's locking? On non-broadcast... Oh, I see. I see. Locking OTP on BCM 2712 devices. Yeah, so you need to. What? Oh, this doesn't make any sense. Okay, it's kind of cool though. Like, I want to make a note about this in my thingy for this project. We want to go note scratchpad. Just make up. So industrial use can set the OTP codes on the Pi for like product, serial number, etc. Yeah, that's kind of cool. Device specific private key. Ooh, nice. File system encryption. Okay, I mean, I'm thinking way too much into this. Like, I do not need this kind of stuff right now, but it's good to know that it's there. Anyway, boot from PCI. Where are we up to? USB boot modes. Blah blah blah. Industrial use. Power button, power supply. Power button? Yeah, we don't have a power button. Real-time clock. RTC. The Pi 5 includes an RTC. Okay. We don't have one of those. We're too cheap for that in our Pi 4 land. Holy shivers, there's so many SPI buses. Crazy. Yeah, anyway. BCM 2711. That's what we got. Alright, I think that's good enough for all of that. Alright, let's restart this beast and see what happens. So we're going to go sudo reboot and goodbye. Now, I didn't plug in the screen, so they actually shut down a Raspberry Pi. Shut down -H now. What does -H do? Halt. sudo halt. Definitely don't want to just pull the plug. Okay. Whoops. Very cookie. Jeepers, go away. Everything. Sudo halt P will do it. Of course, I turn off my Pi properly every time. Yeah. Yeah, I know you do, buddy. You and me both. 2 full Raspberry installs start kernel panicking because of corrupt file system. Really back it up with something. Definitely don't want to pull plug. Sudo shutdown -H now. Alright, well let's give this a go then. See what happens. MidiPunk. That's not going to work. That's the password. Oi. Oh my gosh. Can't type any. Right, list. What did I list? Sudo shut down -H now. Okay, let's have a look at the help for shutdown. Okay. -H is. Oh, okay, equivalent to power off. Lowercase h, equivalent to power off. So -P. So why don't we just do that? So many options to do the same thing. Sudo shut down -P. Oh, whoops. -P now. And boom, it is turned off. You get the flashing green light, which means you can unplug me now. I think that's what that means anyway. I have no idea. Okay, let's plug our screen in. Bring it over here. And let's see what we got. A white screen and then a less white screen, and we got things loading. That screen should go black. Maybe. Maybe not. Did I plug that in right? Did. Oh boy. There now. Oh, I know why. I'm an idiot. I didn't even install the frickin' firmware. Let's go. This is my problem. We've got to go overlays, and we've got to go ls pi tft star. So the one we want is pi tft 28 resistive. So we're going to go sudo nano config.txt, and we're going to go right down the bottom here. And we'll load that after the UARTs. We'll go over. I don't even know if that makes a difference. DT overlay equals pi tft 28 resistive. I'm actually just going to save this because I want to go DT sudo DT overlay pi tft 28 resistive. The help. My gosh. Okay, well actually now we've got a console on there. So that's interesting. Not exactly what I wanted, but something. Okay, let us. I wanted the help on that. That's what I want. Delay between. Okay, so we got FPS, we got SPI bus speed. Debug and rotate. Okay, well, let's just stick with. Let's go FPS. And we're going to go FPS equals 20. What was that? Anyway, 25. Is that right? FPS. Yeah. Speed. I don't know. But that's okay. So now we can go sudo shutdown /p now. And it goes bye-bye. Okay, now let's boot this thing up again. What I do actually want in that mobile view stream, I do want me in there as well sometimes. What I'm going to do, add that. Add a source. Actually, I can do that live. I'm going to go add scene. I'm going to go me boarded. Overlay me boarded. There we go. Now, hey, and I can turn myself on and off. Handy. Okay. Main PC. Yeah, that doesn't. All right. Let's restart this thing. What are you gonna do? That'll be white. All white. Oh, there we go. We got a console. What do we got? FS root FS clean, and then we've got a terminal. Why do we have a terminal? I thought I set that up to not have a terminal. Anyway, let's have a look and see if all the UARTs have loaded. Okay, so let's go ls/dev. And we've got, we don't have 0. So maybe I do need to include, oh wait, hang on. I'm on the wrong freaking thing here. Oh, maybe I do need to include UART 0. But we've got 2, 3, and 5, which is great. So the only one I'm missing is 0. So let's go boot/firmware. Let's go sudo nano config text. Let's go down the bottom here, and so we've got enable UART is that. So we're going to go DT overlay equals UART O, and then we've got the MIDI UART 0 as well. So try that. X sudo reboot. And we will wait. If it's going to reboot. Now I did say quiet on the command line thing. Oh, I remember there's the option to so hang on a minute. All right, let's have a look at the graphics here for a second. Where are the graphics? Like, is it because this is my only display? This is where it's getting pushed out to. So we go ls/dev, and we got tcy. We still don't have 0. What the heck? Maybe it's that enable UART flag. Like, I don't know why. Maybe that needs to be 1. So we've got this FS check repair thing as well, which is probably good. We want to, I guess we want to make all systems look good. So if I go ls/dev, see, I've only got 1 frame buffer. I wonder if I can load in the UART overlay now. DT overlay sudo DT overlay UART 0. Can you do it? That failed to apply. Fair enough. Let's do a let's do another reboot. Sudo reboot. Go. Well, I'm getting tired. I need to go to bed. Alright, well, we're back in. MidiPunk. Wasn't registered itself. Come on, MDNS. Or whatever the hell it is. Register local host names. SSH. Ain't no ready. Let's go. Come on, 192.168. Right now. Oh, there we go. Huh. Okay, let's go ls/dev ttyama 2, 3, and 5. Why do I not have ttyama? I've got ttys0 now, which is UART 1, and I don't want UART 1. That was that enable thing. So we're going to go boot/firmware. We're going to go cat config.txt dt overlay 0235. So let's go sudo dt overlay /h UART 0. But I don't need to change the pin usage of UART 0. What? Oh no, okay. Oh wait. Enable UART 2. Right, okay. So maybe it does actually exist. It should be TTYAMA 0. Something's not right here. Sudo nano config text. Let's have a look. Probably something simple. We've got disable Bluetooth is 1. And we've got all the UARTs enabled. I don't know, I feel like that should do it. So why? We disabled that service like they said in here, didn't we? Oh, where's the configure UART? UART 0 PLO11, primary UART. Raspberry Pi 4. Primary is UART 1, which is the mini UART, and secondary Bluetooth is 0. So dev serial 0 and serial 1 which point to those. Mini UART set to primary UART core clock variable, mini UART disabled. The default state of the enable UART flag depends on which UART is the primary UART. Mini UART is the primary UART in our case. The default state of the enable flag is 0. Yes. So I don't want to use the primary UART for other purposes. That's not what I want to do. I want to enable UART 0 mini disable. Oh, hang on a minute. Disable. Oh, right. Okay. So, oh man, this is backwards and forwards. This is crazy. So, disable BT disables the Bluetooth device and makes the first PL011 the primary UART. So, basically, if we go back up to here, we go primary UART. Default state of enable UART is actually 1. Okay. And that's the situation we're in here. Okay, so, I mean, yeah, that should frickin' work, right? You'd think. You must also disable the system service that initializes the modem. I did that already, right? So, I mean, we could just double check. We could just go out here and we could just go sudo system ctl disable HCI UART. Yeah, I mean, that didn't do anything, so I did that last. Default 14 and 15. So, I mean, I shouldn't need to set those because they're already there. So, I'm just calling DT overlay UART 0 anyway, so that's fine. Yeah, I mean, everything looks in order. That should work. Now, the other thing is the console. I don't want to show the console on the display. Now, I believe there is a in the command line .txt there's an option where I can change where it renders the console to. So let's look that up. Let's go Linux cmd line.txt. There we go. Console. Okay, so I've removed that. Let's sudo nano. Whoa, that's really bright, that web page. Let's go command line.txt. So quiet splash. Console I have removed. TTY AMA 0. I don't have TTY AMA 0. This is annoying. USB HID. I want more. enable. I don't think this is right. This doesn't. That is kernel. Kernel parameters. Beautiful. Hey, look at that. Here we go. Holy moly, this is huge. I'm pretty sure it's to do with the frame buffer. So if I go down to like F, frame buffer devices. I'm pretty sure it's something like FBcon. That a thing? It is not documented there. There isn't one. You need to gather the available options from every component in the Linux kernel. The list would be huge. The entire line also shows up in proc. Crikey dick. Okay, so that is difficult then. So kernel modules. How do I see what kernel modules are installed? How do I know what kernel modules are? ls mod. Okay. Whoa. There we go. Beautiful. Module. STMPE touchscreen. Nice, that's a good one to know. Okay, so we go ls mod and we can see the kernel modules. Okay, that's pretty handy. That's good. ls mod. Let's put a note in there. Where am I going to put it? I'll put it under Linux. Maybe. I don't know. See the kernel modules for command line.txt. So run ls mod. Beautiful. Kind of. Tells you what. Kinda sorta maybe, but not. Okay. And FBTFT. Frame buffer TFT. FBTFT. What is this? What is this then? Hello, hello. We're working stuff out on our own. FBTFT Raspberry Pi. FBTFT overlay. Driving small, and I can't find Linux frame buffer drivers for small TFT LCD display modules. The module FBTFT makes writing drivers for some of these displays very easy. Well, that's cool. I'm not doing that. I just want to know the options. Let's see if it lets do that. So, kernel modules. FBCon. There it is. There it is. My FBCon thing. Since we're using the frame buffer device FB1, we'll configure the X driver FBDev to use that. No, we won't, because what? I'm not running desktop environment, so go away. Calibrate the touchscreen using X input calibrator. Ooh, okay. That sounds fun. I don't know if I need to do that yet though. I'm not gonna play around with the touchscreen until I need to, until I get there. Hi, the FBTFT buffer is now in the Linux kernel staging tree. Cool. Options. So is there a way I can find out FBTFT options? Here we go. Installation. Enable drivers and menu config and build the kernel. Okay. Illy 9340 FB. Okay, so let's grep, bad boy, grep FBTFT. Wait, or do I just want any? I just want FB, don't I? Here we go. Backlight. Used by. The backlight is used by all of those. Okay, GPIO backlight. FB TFT is used by that. What is that? 9340. What is this? LE 9340 LCD controller. Okay. Native root stuff. Bloody bloody blah. SPI. Can't see any options, and let's have a look in FBTFT and see if there is a config. What's this? Don't know. FBTFT device and device tree for the header file. Suppose the display properties. Is there anything like where the hell is like the FBCon and all that sort of stuff? Like where does FBCon come from? Is that in here or is that FBCon? This repository was archived by the owner. LE 9488. Frame buffer. $11 years ago. Crazy. Chemical. Alright. Pi glass perimeter. All I want to know, like, I just want to understand this more, because I don't actually understand where fbcon comes from in command line.txt. fbcon Linux. Why, where's that actually? Oh, the frame buffer console. It's actually, are you serious? It's actually just like a it's like a core frickin' Linux thing. Oh, I've been duped. At least one frame buffer driver is required, so choose from any of the numerous drivers available. Yeah, okay. Common bug is enabling the frame buffer without enabling the frame buffer console. Usually fbcon will take over your console. Notable is a text console running on top of the frame buffer device. My music has just stopped and I don't like it. And is there any way I can, like, no. Okay. Anywho, let's have a look. Frame buffer configuration. fbcon map. There we go. That's where it is. Okay, so I have learnt something new now. There is also a crap load of Linux documentation. Oh my gosh, kernel documentation. Yeah, there's a lot for things like frame buffer configuration, etc. and the like. This is an interesting option. It tells which driver gets mapped to which console. The value 0123 is a sequence that gets repeated until the total length is 64, which is the number of consoles available. And the above example is expanded to that. And the mapping will be 0123023. Okay, so frame buffer. Oh, I get it. Okay, that's interesting. Just like, when you want to map. That's crazy. This be crazy. I need music. Where's my music? Music. What are we doing? Let's go. What's Citadel? No, I don't want that. Dark jazz. I don't want dark jazz. What about 80s Tokyo funky lo-fi play? Working alone, no distraction, deep focus. Well, that sounds about right. I'm working alone right now. God, I hate those ads so much. Okay. Alrighty then. FBCon. Yeah, one side effect is using a map value that exceeds the number of loaded drivers. Only one driver is available. That's our case. So what I'm going to do here is I am going to frame buffer console. So yeah, basically to get rid of that, I need to go sudo nano cmd line.txt, and we're going to go fbcon what's the syntax? fbcon equals map 2. Because we don't have a frame buffer 2. So doing that should mean that if I restart sudo reboot, what should happen is if we look at this, yeah, I shouldn't see a console. The idea when it loads, it should just go black, stay black. I win Linux, yay. Good. Okay, we have great success. We have a black, yes that is black, believe it or not, screen, which taken me a long time to get there. It's amazing. Alright, okie dokie, that's good, and we've understood everything along the way, which is bloody fantastic. Only taken 3 hours. That's actually not that bad. Now I need to this is back in 2020. I don't want to open up a really old like post again. Sometimes I feel like I just want to say, you know, it's, oh by the way, it's here. I looked it up and it's, you know, be helpful. Anyway, moving right along, we got what we got. We don't need that. We don't need that. We don't need configuration anymore because I think because I still haven't got that freaking TTY AMA 0 going. which is a real pain. Yeah, why not? LES TTYA star. Yeah, I got 2, 3, and 5. I don't have serial 0. Why? Okay, I'm just gonna Google this because, like, why not? TTY AMA 0 missing. Raspberry Pi 4. Somebody's searched for this before. Okay. Okay, this is not my problem because alright. Wow, this is crazy. Okay, this isn't helping much at all. Walking to TTY S0 or IMA. What the hell is the HCI UART system actually? I don't even know what that is. What is it like? What is HCI UART? Expose Bluetooth controller support over UART to another device CPU using the H4 protocol. Okay, so HCI UART transport layer. Bluetooth HCI hardware NECT interface or something? What is HCI? What does HCI stand for? Human computer? No. Bluetooth. Bluetooth. Host controller interface. Okay. Right. Okay. Okay. Oh, that makes sense. That makes sense. Alright, so what I'm trying to do here is go cd/boot/firmware, and we're going to go to sudo nano config.txt again, our old fave. And we're going to go enable, oops, Disable Bluetooth. Now hang on a minute. Oh, you idiot. That's why. Oh, I'm such a dumb. Okay, DT overlay equals disable BT. Shoot. So I don't even know if I need that then. Okay, let's go Control O, Control X. Let's go sudo reboot. This might be the kicker. When in doubt, check your frickin' spelling, what you've typed in. Makes sense. Unbelievable. Okay. This should be it though. This should give us our all of our UART ports that we need. I thought I was being so careful reading all those instructions. Well, I was. It was a small mistake. It's fine. No problem. Let's go. ls/dev and TTYAMA0235. Suck on that. I mean, yeah, it's fine. We're good. Oh my gosh. Okay. I am set up. The Pi, the Raspberry, delicious Raspberry Pi is baked, cooked. Whatever the hell you want to say. Why is TTYS0 still there? Oh, it's because, I know why, because we actually still have the mini UART available. Now, the question I have, though, is doesn't that, like, what one wins the pins? So, okay, what I'm going to do, I'm going to do one more thing here. I'm going to go boot/firmware/config. I'm going to edit that. And I'm going to go... This is just going to be a bit of a play around. Enable UART equals 0, right? So we're gonna try and get rid of the mini UART completely, so that's not converging or fighting over the pins of the hardware UART. I mean, maybe it doesn't matter. Maybe they can be both piped into the same thing anyway. Maybe they can actually share the pins. I doubt it. But maybe they're like in parallel or something. It doesn't actually matter. The only way I can find that out is by trying. But I'm not going to bother because I'm not going to use mini UART. So, who cares? Maybe I will use it later when I don't know. Trying to get Bluetooth MIDI working or something. ls/dev TTYAMA0235. Beautiful. And we don't... Oh, we've still got S0. What? Dev? Hello? So that's going to TTYAMA0. Okay, so that's good. That's good. And so we can probably then... There is a way to look at the pin status. How do you see pin status Raspberry Pi? The way to look at that, there is... can't remember what it is. Yes, that's exactly my problem here. GPIO utility from Wiring Pi. GPIO. Type in the terminal. Okay, what Wiring Pi? Oh, Raspberry GPIO. Yeah. That's it. I might make a note of that. Raspberry Pi general how-tos. GPIO in it up. Which was Raspberry Pi. Yeah. Alright, here we go. Let's have a look. Bank. GPIO 14 and 15. We've got TXD0, RXD0. Oh, perfect. Okay, so we've got 0, 2, 3, and we should have 5. 0, 2, 3, 5. Hell yes. Okay, that's perfect. So that's great. That's exactly what I want. Good. Good. Alright. Perfecto. Oh, it's time for me to go to bed. No one's here, so good night, nobody. But if anyone watches the VOD for some strange reason, I should come watch the stream one day and talk to me, because I'm more interesting when people are actually talking to me instead of just talking to myself like I'm doing right now. Guten Nacht. Bis morgen. Auf Wiedersehen. Schlaf gut. Guten Schlaf. I freaking don't know. Let's turn this thing off. So let's go sudo shutdown. Now. Good night.